WiMAX is a wireless communications standard designed to provide 30 to 40 megabit per second data rates, with the 2011 update providing up to 1 Gbit for fixed stations. The name WiMAX was created by the WiMAX Forum, which was formed in June 2001 to promote conformity and interoperability of the standard. The forum describes WiMAX as a standards-based technology enabling the delivery of last-mile wireless broadband access as an alternative to cable and DSL. Terminology: WiMAX refers to interoperable implementations of the IEEE 802.16 family of wireless networks standards ratified by the WiMAX Forum. WiMAX Forum certification allows vendors to sell fixed or mobile products as WiMAX certified, thus ensuring a level of interoperability with other certified products, as long as they fit the same profile. The original IEEE 802.16 standard was published in 2001. WiMAX adopted some of its technology from WeBRO, a service marketed in Korea. Mobile WiMAX is the revision that was deployed in many countries, and basis of future revisions such as 802.16m 2011. WiMAX is sometimes referred to as Wi-Fi on steroids, and can be used for a number of applications including broadband connections, cellular backhaul, hotspots, etc. It is similar to Wi-Fi, but it can enable usage at much greater distances. Uses: the bandwidth and range of WiMAX make it suitable for the following potential applications: providing portable mobile broadband connectivity across cities and countries through a variety of devices. Providing a wireless alternative to cable and digital subscriber line for last-mile broadband access. Providing data, telecommunications and IPTV services. Providing a source of Internet connectivity as part of a business continuity plan. Smart grids and metering, Internet access. WiMAX can provide at-home or mobile Internet access across whole cities or countries. In many cases this has resulted in competition in markets which typically only had access through an existing incumbent DSL operator. Additionally, given the relatively low costs associated with the deployment of a WiMAX network, it is now economically viable to provide last-mile broadband Internet access in remote locations. Middle-mile backhaul to fiber networks. Mobile WiMAX was a replacement candidate for cellular phone technologies such as GSM and CDMA, or can be used as an overlay to increase capacity. Fixed WiMAX is also considered as a wireless backhaul technology for 2G, 3G, and 4G networks in both developed and developing nations. In North America, backhaul for urban operations is typically provided via one or more copper wire line connections, whereas remote cellular operations are sometimes backhauled via satellite. In other regions, urban and rural backhaul is usually provided by microwave links. WiMAX has more substantial backhaul bandwidth requirements than legacy cellular applications. Consequently, the use of wireless microwave backhaul is on the rise in North America, and existing microwave backhaul links in all regions are being upgraded. Capacities of between 34 Mbps and 1 Gbs are routinely being deployed with latencies in the order of 1 ms. In many cases, operators are aggregating sites using wireless technology and then presenting traffic onto fiber networks where convenient. WiMAX in this application competes with microwave, E-line and simple extension of the fiber network itself. Triple play. WiMAX directly supports the technologies that make triple play service offerings possible. These are inherent to the WiMAX standard rather than being added on as carrier Ethernet is to Ethernet. On May 7, 2008 in the United States, Sprint, Nextel, Google, Intel, Comcast, Bright House, and Time Warner announced a pooling of an average of 120 MHz of spectrum and merged with Clearwire to market the service. The new company hopes to benefit from combined services offerings and network resources as a springboard past its competitors. The cable companies will provide media services to other partners while gaining access to the wireless network as a mobile virtual network operator to provide triple play services. Some analysts questioned how the deal will work out. Although fixed mobile convergence has been a recognized factor in the industry, prior attempts to form partnerships among wireless and cable companies have generally failed to lead to significant benefits to the participants. Other analysts point out that as wireless progresses to higher bandwidth, it inevitably competes more directly with cable and DSL, inspiring competitors into collaboration. Also, as wireless broadband networks grow denser and usage habits shift, the need for increased backhaul and media service will accelerate, therefore the opportunity to leverage cable assets is expected to increase. Connecting. Devices that provide connectivity to a WiMAX network are known as subscriber stations. Portable units include handsets, PC peripherals, and embedded devices in laptops, which are now available for Wi-Fi services. In addition, there is much emphasis by operators on consumer electronics devices such as gaming consoles, MP3 players and similar devices. WiMAX is more similar to Wi-Fi than to other 3G cellular technologies. The WiMAX Forum website provides a list of certified devices. However, this is not a complete list of devices available, as certified modules are embedded into laptops, MIDs, and other private labeled devices. Gateways. WiMAX gateway devices are available as both indoor and outdoor versions from several manufacturers including Versima Networks, Alvarian, S-Pan, Zyxel, Huawei, and Motorola. The list of deployed WiMAX networks and WiMAX Forum membership list provide more links to specific vendors, products and installations. The list of vendors and networks is not comprehensive and is not intended as an endorsement of these companies above others. Many of the WiMAX gateways that are offered by manufacturers such as these are standalone self-install indoor units. Such devices typically sit near the customer's window with the best signal, and provide an integrated Wi-Fi access point to provide the WiMAX internet connectivity to multiple devices throughout the home or business. Ethernet ports to connect directly to a computer, router, printer or DVR on a local wired network. 1 or 2 analog telephone jacks to connect a landline phone and take advantage of VoIP. Indoor gateways are convenient, but radio losses mean that the subscriber may need to be significantly closer to the WiMAX base station than with professionally installed external units. Outdoor units are roughly the size of a laptop PC, and their installation is comparable to the installation of a residential satellite dish. A higher gain directional outdoor unit will generally result in greatly increased range and throughput, but with the obvious loss of practical mobility of the unit. External modems, USB, can provide connectivity to a WiMAX network through what is called a dongle. Generally these devices are connected to a notebook or netbook computer. Dongles typically have omnidirectional antennas which are of lower gain compared to other devices. As such, these devices are best used in areas of good coverage. Mobile phones. HTC announced the first WiMAX-enabled mobile phone, the Max 4G, on November 12, 2008. The device was only available to certain markets in Russia on the Yota network. HTC and Sprint Nextel released the second WiMAX-enabled mobile phone, the EVO 4G, March 23, 2010 at the CTIA conference in Las Vegas. The device, made available on June 4, 2010, is capable of both EV2, 3G, and WiMAX, pre-4G, as well as simultaneous data and voice sessions. Sprint Nextel announced at CES 2012 that it will no longer be offering devices using the WiMAX technology due to financial circumstances. Instead, along with its network partner Clearwire, Sprint Nextel will roll out a 4G network, deciding to shift and utilize LTE 4G technology instead. Technical information: the IEEE 802.16 standard, WiMAX is based upon IEEE STD 802.16E-2005, approved in December 2005. It is a supplement to the IEEE STD 802.16-2004, and so the actual standard is 802.16-2004 as amended by 802.16E-2005. Thus, these specifications need to be considered together. IEEE 802.16E-2005 improves upon IEEE 802.16-2004 by adding support for mobility. This is seen as one of the most important aspects of 802.16E-2005, and is the very basis of mobile WiMAX. Scaling of the fast Fourier transform to the channel bandwidth in order to keep the carrier spacing constant across different channel bandwidths. Constant carrier spacing results in a higher spectrum efficiency in wide channels, and a cost reduction in narrow channels. Also known as scalable OFDMA. Other bands not multiples of 1.25 MHz are defined in the standard, but because the allowed FFT subcarrier numbers are only 128, 512, 1024 and 2048, other frequency bands will not have exactly the same carrier spacing, which might not be optimal for implementations. Carrier spacing is 10.94 kHz. Advanced antenna diversity schemes, and hybrid automatic repeat request, adaptive antenna systems and MIMO technology, denser sub-channelization, thereby improving indoor penetration, intro and low-density parity check, introducing downlink sub-channelization, allowing administrators to trade coverage for capacity or vice versa, adding an extra quality of service class for VoIP applications. SOFDMA and OFDM256 are not compatible, thus equipment will have to be replaced if an operator is to move to the latest standard. Physical layer. The original version of the standard on which WiMAX is based specified a physical layer operating in the 10 to 66 GHz range. 802.16 updated in 2004 to 802.16-2004, added specifications for the 2 to 11 GHz range. 802.16-2004 was updated by 802.16e-2005 in 2005 and uses scalable orthogonal frequency division multiple access, as opposed to the fixed orthogonal frequency division multiplexing version with 256 subcarriers in 802.16d. More advanced versions, including 802.16e, also bring multiple antenna support through MIMO. This brings potential benefits in terms of coverage, self-installation, power consumption, frequency reuse and bandwidth efficiency. WiMAX is the most energy-efficient pre-4G technique among LTE and HSPA+. Media Access Control Layer. The WiMAX MAC uses a scheduling algorithm for which the subscriber station needs to compete only once for initial entry into the network. After network entry is allowed, the subscriber station is allocated an access slot by the base station. The time slot can enlarge and contract, but remains assigned to the subscriber station, which means that other subscribers cannot use it. In addition to being stable under overload and oversubscription, the scheduling algorithm can also be more bandwidth efficient. The scheduling algorithm also allows the base station to control quality of service parameters by balancing the time slot assignments among the application needs of the subscriber station. Specifications. As a standard intended to satisfy needs of next-generation data networks, WiMAX is distinguished by its dynamic burst algorithm modulation adaptive to the physical environment the RF signal travels through. Modulation is chosen to be more spectrally efficient. That is, when the bursts have a high signal strength and a high carrier-to-noise plus interference ratio, they can be more easily decoded using digital signal processing. In contrast, operating in less favorable environments for RF communication, the system automatically steps down to a more robust mode, which means fewer bits per OFDM/SOFDMA symbol. With the advantage that power per bit is higher and therefore simpler accurate signal processing can be performed. Burst profiles are used inverse to low signal attenuation. Meaning throughput between clients and the base station is determined largely by distance. Maximum distance is achieved by the use of the most robust burst setting. That is, the profile with the largest MAC frame allocation trade-off requiring more symbols to be allocated in transmitting a given amount of data than if the client were closer to the base station. The client's MAC frame and their individual burst profiles are defined as well as the specific time allocation. However, even if this is done automatically, then the practical deployment should avoid high interference and multipath environments. The reason for which is obviously that too much interference causes the network to function poorly and can also misrepresent the capability of the network. the system is complex to deploy as it is necessary to track not only the signal strength and CINR but also how the available frequencies will be dynamically assigned. This could lead to cluttered frequencies with slow response times or lost frames. As a result, the system has to be initially designed in consensus with the base station product team to accurately project frequency use, interference, and general product functionality. The Asia-Pacific region has surpassed the North American region in terms of 4G broadband wireless subscribers. There were around 1.7 million pre-WiMAX and WiMAX customers in Asia, 29% of the overall market, compared to 1.4 million in the USA and Canada. Integration with an IP-based network. The WiMAX Forum has proposed an architecture that defines how a WiMAX network can be connected with an IP-based core network, which is typically chosen by operators that serve as Internet service providers. Nevertheless, the WiMAX BS provides seamless integration capabilities with other types of architectures as with packet-switched mobile networks. The WiMAX Forum proposal defines a number of components, plus some of the interconnections between these, labeled R1 to R5 and R8, SSMIS, the Subscriber Station Mobile Station, ASN, the Access Service Network, BS, Base Station, part of the ASN, ASN-GW, the ASN Gateway, part of the ASN, CSN, the Connectivity Service Network, HA, Home Agent, part of the CSN, AAA, Authentication, Authorization and Accounting Server, part of the CSN, NAP, a Network Access Provider, NSP, a Network Service Provider. It is important to note that the functional architecture can be designed into various hardware configurations rather than fixed configurations. For example, the architecture is flexible enough to allow remote mobile stations of varying scale and functionality and base stations of varying size, for example femto, pico, and mini-BS as well as macros. Spectrum allocation. There is no uniform global licensed spectrum for WiMAX, however the WiMAX Forum has published 3 licensed spectrum profiles, 2.3 GHz, 2.5 GHz and 3.5 GHz, in an effort to drive standardization and decrease cost. In the USA, the biggest segment available is around 2.5 GHz, and is already assigned, primarily to Sprint Nextel and Clearwire. Elsewhere in the world, the most likely bands used will be the Forum-approved ones, with 2.3 GHz probably being most important in Asia. Some countries in Asia like India and Indonesia will use a mix of 2.5 GHz, 3.3 GHz and other frequencies. Pakistan's Wateen Telecom uses 3.5 GHz. Analog TV bands may become available for WiMAX usage, but await the complete rollout of digital TV, and there will be other users suggested for that spectrum. In the USA, the FCC auction for this spectrum began in January 2008 and, as a result, the biggest share of the spectrum went to Verizon Wireless and the next biggest to AT&T. Both of these companies have stated their intention of supporting LTE, a technology which competes directly with WiMAX. EU Commissioner Viviane Reding has suggested reallocation of €500 800 MHz spectrum for wireless communication, including WiMAX. WiMAX profiles define channel size, TDD, FDD and other necessary attributes in order to have interoperating products. The current fixed profiles are defined for both TDD and FDD profiles. At this point, all of the mobile profiles are TDD only. The fixed profiles have channel sizes of 3.5 MHz, 5 MHz, 7 MHz and 10 MHz. The mobile profiles are 5 MHz, 8.75 MHz and 10 MHz. Since October 2007, the radio communication sector of the International Telecommunication Union has decided to include WiMAX technology in the IMT 2000 set of standards. This enables spectrum owners to use WiMAX equipment in any country that recognizes the IMT 2000. Spectral efficiency. One of the significant advantages of advanced wireless systems such as WiMAX is spectral efficiency. For example, 802.16-2004 has a spectral efficiency of 3.7 pHz, and other 3.5 Euro 4G wireless systems offer spectral efficiencies that are similar to within a few tenths of a percent. The notable advantage of WiMAX comes from combining SOFDMA with smart antenna technologies. This multiplies the effective spectral efficiency through multiple reuse and smart network deployment topologies. The direct use of frequency domain organization simplifies designs using MIMOAA as compared to CDMA/WCDMA methods, resulting in more effective systems. Inherent limitations: WiMAX cannot deliver 70 Mbps over 50 km. Like all wireless technologies, WiMAX can operate at higher bit rates or over longer distances but not both. Operating at the maximum range of 50 km increases bit error rate and thus results in a much lower bit rate. Conversely, reducing the range allows a device to operate at higher bit rates. A citywide deployment of WiMAX in Perth, Australia demonstrated that customers at the cell edge with an indoor customer premises equipment typically obtain speeds of around 1 Euro 4 Mbps, with users closer to the cell site obtaining speeds of up to 30 Mbps. Like all wireless systems, available bandwidth is shared between users in a given radio sector, so performance could deteriorate in the case of many active users in a single sector. However, with adequate capacity planning and the use of WiMAX's quality of service, a minimum guaranteed throughput for each subscriber can be put in place. In practice, most users will have a range of 4-8 Mbps services and additional radio cards will be added to the base station to increase the number of users that may be served as required. Silicon implementations. A number of specialized companies produced baseband ICs and integrated RFICs for WiMAX subscriber stations in the 2.3, 2.5 and 3.5 GHz bands. These companies include, but are not limited to, Basim, Sequans, and PicoChip. Comparisons and confusion between WiMAX and Wi-Fi are frequent, because both are related to wireless connectivity and Internet access. WiMAX is a long-range system, covering many kilometers, that uses licensed or unlicensed spectrum to deliver connection to a network, in most cases the Internet. Wi-Fi uses unlicensed spectrum to provide access to a local network. Wi-Fi is more popular in end-user devices. Wi-Fi runs on the Media Access Control's CSMA/CA protocol, which is connectionless and contention-based, whereas WiMAX runs a connection-oriented MAC. WiMAX and Wi-Fi have quite different quality of service mechanisms. WiMAX uses a coax mechanism based on connections between the base station and the user device. Each connection is based on specific scheduling algorithms. Wi-Fi uses contention access. All subscriber stations that wish to pass data through a wireless access point are competing for the AP's attention on a random interrupt basis. This can cause subscriber stations distant from the AP to be repeatedly interrupted by closer stations, greatly reducing their throughput. Both IEEE 800 2.11, which includes Wi-Fi, and IEEE 800 2.16, which includes WiMAX, define peer-to-peer and wireless ad hoc networks, where an end user communicates to users or servers on another local area network using its access point or base station. However, 802.11 supports also direct ad hoc or peer-to-peer networking between end-user devices without an access point, while 802.16 end-user devices must be in range of the base station. Although Wi-Fi and WiMAX are designed for different situations, they are complementary. WiMAX network operators typically provide a WiMAX subscriber unit that connects to the metropolitan WiMAX network and provides Wi-Fi connectivity within the home or business for local devices, for example, computers, Wi-Fi handsets and smartphones. This enables the user to place the WiMAX subscriber unit in the best reception area, such as a window, and still be able to use the WiMAX network from any place within their residence. The local area network inside one's house or business would operate as with any other wired or wireless network. If one were to connect the WiMAX subscriber unit directly to a WiMAX-enabled computer, that would limit access to a single device. As an alternative for a LAN, one could purchase a WiMAX modem with a built-in wireless Wi-Fi router, allowing one to connect multiple devices to create a LAN. Using WiMAX could be an advantage, since it is typically faster than most cable modems with download speeds between 3 and 6 Mbps, and generally costs less than cable. Conformance testing. TTCN3 test specification language is used for the purposes of specifying conformance tests for WiMAX implementations. The WiMAX test suite is being developed by a specialist task force at ETSI. Associations. WiMAX Forum. The WiMAX Forum is a non-profit organization formed to promote the adoption of WiMAX-compatible products and services. A major role for the organization is to certify the interoperability of WiMAX products. Those that pass conformance and interoperability testing achieve the WiMAX Forum certified designation, and can display this mark on their products and marketing materials. Some vendors claim that their equipment is WiMAX ready, WiMAX compliant, or pre-WiMAX, if they are not officially WiMAX Forum certified. Another role of the WiMAX Forum is to promote the spread of knowledge about WiMAX. In order to do so, it has a certified training program that is currently offered in English and French. It also offers a series of member events and endorses some industry events. WiMAX Spectrum Owners Alliance, WISO, was the first global organization composed exclusively of owners of WiMAX spectrum with plans to deploy WiMAX technology in those bands. WISO focused on the regulation, commercialization, and deployment of WiMAX spectrum in the 2.3 Euro 2.5 GHz and the 3.4 Euro 3.5 GHz ranges. WISO merged with the Wireless Broadband Alliance in April 2008. Telecommunications Industry Association. In 2011, the Telecommunications Industry Association released 3 technical standards that cover the air interface and core networking aspects of WiMAX high-rate packet data systems using a mobile station access terminal with a single transmitter. Competing technologies. Within the marketplace, WiMAX's main competition came from existing, widely deployed wireless systems such as Universal Mobile Telecommunications System, CDMA 2000, existing Wi-Fi and mesh networking. In the future, competition will be from the evolution of the major cellular standards to 4G, high bandwidth, low latency, all IP networks with voice services built on top. The worldwide move to 4G for GSM UMTS and UMTS-TIA is the 3GPP long-term evolution effort. The LTE standard was finalized in December 2008. With the first commercial deployment of LTE carried out by TeliaSonera in Oslo and Stockholm in December 2009. Since then, LTE has seen increasing adoption by mobile carriers around the world. In some areas of the world, the wide availability of UMTS and a general desire for standardization has meant spectrum has not been allocated for WiMAX. In July 2005, the EU-wide frequency allocation for WiMAX was blocked. Harmonization. Early wireless MAN standards, the European standard HIPAA-MAN and Korean standard WiBRO were harmonized as part of WiMAX and are no longer seen as competition but as complementary. All networks now being deployed in South Korea, the home of the WiBRO standard, are now WiMAX. Comparison with other mobile Internet standards. The following table only shows peak rates which are potentially very misleading. In addition, the comparisons listed are not normalized by physical channel size. This obfuscates spectral efficiency and net throughput capabilities of the different wireless technologies listed below. Notes: all speeds are theoretical maximums and will vary by a number of factors, including the use of external antennas, distance from the tower and the ground speed. Usually the bandwidth is shared between several terminals. The performance of each technology is determined by a number of constraints, including the spectral efficiency of the technology, the cell sizes used, and the amount of spectrum available. For more information, see Comparison of wireless data standards. For more comparison tables, see bit rate progress trends, comparison of mobile phone standards, spectral efficiency comparison table and OFDM system comparison table. Development. The IEEE 802.16m 2011 standard was the core technology for WiMAX 2. The IEEE 802.16m standard was submitted to the ITU for IMT Advanced Standardization. IEEE 802.16m is one of the major candidates for IMT Advanced Technologies by ITU. Among many enhancements, IEEE 802.16m systems can provide 4 times faster data speed than the WiMAX Release 1. WiMAX Release 2 provided backward compatibility with Release 1. WiMAX operators could migrate from Release 1 to Release 2 by upgrading channel cards or software. The WiMAX 2 collaboration initiative was formed to help this transition. It was anticipated that using 4x2 MIMO in the urban microcell scenario with only a single 20 MHz TDD channel available system-wide, the 802.16m system can support both 120 Mbit/s downlink and 60 Mbit/s uplink per site simultaneously. It was expected that the WiMAX Release 2 would be available commercially in the 2011-2012 timeframe. Interference, a field test conducted in 2007 by SUIG with support from the U.S. Navy, the Global VSAT Forum, and several member organizations yielded results showing interference at 12 km when using the same channels for both the WiMAX systems and satellites in C-band. Deployments. As of October 2010, the WiMAX Forum claimed over 592 WiMAX networks deployed in over 148 countries, covering over 621 million subscribers. By February 2011, the WiMAX Forum cited coverage of over 823 million people, and estimate over 1 billion subscribers by the end of the year. South Korea launched a WiMAX network in the second quarter of 2006. By the end of 2008 there were 350,000 WiMAX subscribers in Korea. Worldwide, by early 2010 WiMAX seemed to be ramping quickly relative to other available technologies, though access in North America lagged. Yota, the largest WiMAX network operator in the world in 4Q 2009, announced in May 2010 that it will move new network deployments to LTE and, subsequently, change its existing networks as well. A study published September 2010 by Bleacroft Publishing estimated 800 management contracts from 364 WiMAX operations worldwide offering active services. See also. Notes. References. External links, official page of the WiMAX Forum, How WiMAX Works at How Stuff Works, Internet Protocol Journal Overview of Mobile WiMAX, Patent Alliance formed for WiMAX 4G technology. WiMAX vs LTE, Mobile WiMAX Throughput Measurements, Prashant Sharma. Facts about WiMAX and why is it the future of wireless broadband? Tech Pluto blog. Retrieved August 26, 2011 A.